Hello everyone, I am Sonam Yadav, Assistant Professor in Biyani Group of Colleges. Today my topic is Kepler's law of planetary motion. So before starting, Kepler in 1609 discovered some laws for planetary motion of an orbit. So first law is every planet moves in elliptical orbit and the focus is at Sun. Second law given by Kepler is the area swept per second by the line joining planet to the Sun is always constant. The line joining planet to the Sun, that is the distance, and the area covered per second by the line joining planet to the Sun is always constant, and mathematically we can say that 1 by r squared d theta by dt is constant. And the third one is the square of time period of planet is directly proportional to the cube of semi-major axis of the orbit, and mathematically we can say t square is directly proportional to a cube. The third law of Kepler we can say is more important law. So we should know the mathematically t square is always directly proportional to a cube. So after the studying of these laws, Newton conclude over these planetary motions law. So we'll study about that one also on the basis of Kepler's law. Mainly from Kepler's third law, Newton gave his conclusion using Kepler's third law. So for that, he assumed a planet of mass m is moving in circular orbit of radius r and with velocity v. So therefore we can say that the semi-major axis, like we can say a mass or a planet is moving like this. So this we called is semi-major axis, and this one is semi-minor axis. And according to Kepler's third law, the square of time period is directly proportional to cube of that semi-major axis. But here when a planet is moving in circular orbit, so we can assume the semi-major axis, that is a, can be equals to the radius of the orbit, and radius is r. Okay. So here we also can write t square is directly proportional to r cube, and if we remove the proportional, so it will become r cube, where k is constant, where k is some constant. So after getting this, let the angular velocity of that planet is omega. So omega, we know that what's the value of omega is 2 pi by t. So on squaring, omega square is equals to 4 pi by t square. So we know that a particle is moving in circular orbit, so there will be some centripetal force acting on that particle. So what will be that one? So the centripetal force acting on that planet will be given as F, and the value of centripetal force is F m omega square r. So after putting the value of omega square, that is 4 pi square by E, is we get 4 pi square m by k r cube. So on the basis of Kepler's law, Newton gave some conclusion. The first one is centripetal force acting on that planet is always from the planet towards Sun, and the second one is the radius will be inversely proportional to the force, or we can say force is inversely proportional to the square of that radius. Radius is planet to the Sun, the distance between planet to the Sun. Third one is the force is directly proportional to the mass. Also Newton said the centripetal force acts not only between the planets, but it also can act between two masses, two particles. So that's all for the Kepler's law, or Newton's conclusion from Kepler's law. Thank you. Hope you like this video, and I request you to please like and share this video and subscribe our channel, that is Group KPU. Thank you.